Hi guys, today we wanted to present our group project which is early detection of COVID-19. The coronavirus disease, which is known as COVID-19, caused by the virus SARS-CoV-2, is the greatest threat not only to global health but also has far-reaching socio-economic impact on nearly all the countries in the world. In Malaysia, the first case was reported on the 25th January 2020. The first death due to SARS-CoV-2 infection was on the 17th March 2020. Testing for COVID-19 enables infected individuals to be identified and isolated to reduce spread, allows contact tracing for exposed individuals, and provide knowledge of regional and national rates of infection to inform public health interventions. However, making people queue up the test is consuming a lot of time and energy. Problem statement: the lack of early detection for COVID-19 could be dangerous to the society and individual. The virus could spread widely if the person that have been infected to COVID-19 did not take action by identifying the symptoms by themselves first. Early detection systems for COVID-19 are suggested to develop to help people aware with their conditions so that they can take an appropriate action if they notice they were in the high risk to get infected by COVID-19. Early detection can help to stop the COVID-19 from spreading faster.
I will continue with the method. The parameters taken for a study of COVID-19 patient data are age, chronic diseases, staff, student, live in a communal setting, outside of Malaysia, in contact with COVID-19 patient and have one or more symptoms. We adopted fuzzy logic as an intelligent technique. Fuzzy logic is a model that represents the reliable aspect of the behavior of the system. This can help the user understand better of the system than being able to forecast and control its behavior. The simple fuzzy model consists of a set of rules with an if-then structure. The condition 1 and 2 mean the premises. The conclusion is set which represent all the linguistic terms that express the flexibility predictor which characterize the output behavior of the system if all conditions are satisfied. The knowledge base express the relationship between input and output fuzzy variable. Input are from the user which are yes 1 or no 0 answer. We also use the MATLAB as a tool to train the data. This tool can integrate computational visualization and in the programming environment. Based on Hugo 2005, the data structure in this tool contains the built-in editing, debugging tool and support object-oriented programming. This MATLAB is used to develop the algorithm to classify the right percentage of a user to have been affected by the COVID-19.
Results. Based on the input provided by the patient or user, the system calculates the percentage of COVID-19 infection rate. The box over there displays the percentage of COVID-19 infection rate. Low risk is between 0% to 40%. Middle or medium risk is between 41% to 79%. High risk is between 80% to 100%. Figure 4 shows the result of patient with medium risk of COVID-19 infection. So if you see here, these are the information that has to be filled in by the patients. They have to fill in their age, and then for the rest of the information they have to fill in either 1 or 0. 1 means yes, 0 means no. So for this particular patient over here, he or she is 12 years old, no chronic diseases, lives in communal setting, have not been outside of Malaysia within the past 14 days period, have not been in contact with COVID-19 patients, and have one or more symptoms of COVID-19 infection. The percentage displayed by the system for this patient is 47.2805. That means this patient is in middle risk or medium risk of COVID-19 infection. Figure 5 shows the result of patient with low risk of COVID-19 infection. This patient is 20 years old, have no chronic diseases, have not been living in communal setting, have not been outside of Malaysia for the past 14 days, have not been in contact with COVID-19 patients, and don't have any symptoms of COVID-19 infection. The percentage of COVID-19 infection for this patient is 34.0629%. So this person has low risk of COVID-19 infection. Figure 6 shows the result of patient with medium. Figure 7 shows the result of patient with high risk of COVID-19 infection. This patient is 60 years old, have chronic disease, lives in communal setting, has been outside of Malaysia within the past 14 days period, in contact with COVID-19 patients and have one or more symptoms of COVID-19 infection. The percentage displayed for this patient is 93.6667. That means this patient is in high risk of being infected by COVID-19.
Hello, my name is Najiha. I will present about our applications and the rule will correct these apps. In order to simplify the methods of data input, the early COVID-19 detections GUI was corrected, where user only need to insert the data and generate outcome in few steps. This is how our GUI functions. First, insert your age, and after insert all this, run the applications. And early detections is about 93% is quite high for this user to get COVID-19. So this application can reset, so all blank. So insert 20 years old. And run the application, and it will get 72%. So it's in middle risk for this user, and exit the applications. Fuzzy set is about fuzzy set is defined using the linguistic conditional statement with the if-then statement using binary logic. It is used to express a piece of expert knowledge in fuzziness. In this fuzzy system, the fuzzy rules are identified according to general conditions. All these rules are correct to help the outcome predictions. For example, if the age is older, then 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 have a then its result is high risk for COVID-19. Another example. If the age is older and have a chronic disease, so and maybe he is tough KKM, then result is risk high for her or his. So to correct this system, it's take about 277 rules. Okay, thank you.
As a conclusion, fuzzy logic offers a straightforward way to arrive at definite conclusion. Fuzzy logic uses a straightforward rule-based if X and Y then Z approach to problem resolution rather than trying to mathematically model a system. This method outlines a design for a user-informed framework for evaluating the probability of COVID-19 patients being identified and can be used for the field. This strategy can be further improved by increasing the rule on knowledge from one patient and by including the neural network from the other side.